702. The Naked Scientist.
Give us a call right now. Any question you have about science, the wonderful world around us, curiosities that you've been puzzling through but unable to solve them. Chris will answer your questions about anything and everything in the world of science. Chris, good morning.
Hello.
The very first image of a black hole.
Yeah, I know. And it's not just Zimbabwe's finances.
Ooh.
I couldn't resist that. No, this has been amazing news this week. There's been pictures beamed of this all around the world, but this is the amazing tour de force of a big international team of scientists, some of which include scientists in South Africa. And this Event Horizon Telescope team have managed to image the black hole at the centre of M87, Messier 87, a distant galaxy. It's millions of light years away. But it's enormous, this black hole. It's 6 billion times the mass of our own sun. And they're also going to turn their attention on Sagittarius A, which is the black hole at the centre of our Milky Way galaxy. Maybe they're saving the best to last, who knows? But this is a really amazing feat because although physics had predicted black holes, we had measured indirectly their presence using things like gravitational lensing, and there are various other things that have suggested that they're there. No one's ever seen one by virtue of the fact that because these things are so massive and they distort space-time to such an extreme that not even light can escape. So any light that goes in basically is warped into this never-ending spiral and disappears and you can't see them. Apart from that, we've never actually directly been able to see all of the material around a black hole and make these sorts of measurements. And so what they did is to take 8 individual, very powerful telescopes across the Earth's surface in different venues, right down from the southern hemisphere up to the northern hemisphere. So you're effectively creating a planet-sized telescope, and they stitch all of the information from each telescope, which is all overlapping a bit, together. And the overlapping stitched image produces a much more powerful image than any individual telescope could produce on its own. So although we had the capacity to make the sorts of measurements that have ended up forming these images, we didn't have the ability to stitch them all together. And that's taken new advances in thinking about how we do image processing and so on. So a really amazing piece of work and just the beginning, really. So actually the pictures that they circulated look a bit like a bagel. And that's because you've got the black hole, which is the intensely dense thing in the middle, and it's surrounded by gas and dust, which are being accelerated as they fall in under the intense gravitational acceleration of the black hole. And as they swirl round, they're being heated to billions of degrees. And as they're heated to billions of degrees, they give off energy in radiation. And that's the light energy that's making its way back to Earth that's in these pictures.
Wendy, good morning. Welcome to the show.
Okay, my question is, when I take my nail polish off my nails, if I don't have nail polish on, my nails pain.
Do you mean they physically hurt you, Wendy?
Yes, it does. It pains. I have to, if I take my nail polish off, I wash, and then after about an hour or two, my nail bed actually starts paining. They're sore.
Yeah.
And then I'll put nail polish on again and it goes away.
This is the naked beautician and the naked manicurist show now. Okay.
Yeah. Capitalists are very clever. They've made your nails miss the nail polish.
Well, I think what could be going on here, Wendy...
And she's not the only one, Chris. A couple of other women are saying the same thing. There's a
really?
phenomenon here.
So, okay, yeah. Well, there's something in this. Well, we'll have to do the experiment, obviously. I'm going to speculate on an answer for you, Wendy. So don't take this as gospel until I've had a chance to actually look into this a bit more. But my speculation is nail polish is very stiff. Once it goes on your nail, it produces a very stiff surface. And nails are flexible because as they grow, the nail bed is growing and pushing out more of the keratin that the nail is made from. It's possible that when you put the nail polish on, it stiffens and holds the nail in a very rigid position. And then when you take it off, the nail has got used to being splinted in that way, and it then starts to move a bit and adopt the more normal position for where it would prefer to be without the nail polish rigidly stapling it in position. And it could be that that's almost expansion or movement of the tissue is what's making it feel uncomfortable. I think if you were to leave it for a little while, it would all settle down and be absolutely fine. But I suspect that's the reason. It's the stiffness and rigidity imparted to the nail by the nail polish, holding it in a slightly unnatural position for where it would like to be. So when you remove that splint, you then end up with your nail flowing and deforming a bit back to the shape it would prefer to be in, and that's when it becomes uncomfortable.
Yeah, amazing how many people say yes. No, I totally agree with Wendy. I wouldn't have known. And Corsi wants to know on Twitter, Chris, what is the GI in low GI bread, and are there genuine health benefits?
Well, GI stands for glycemic index, and glycemia is the level of sugar in your bloodstream. So we can look at a food and we can ask, if I eat this, how quickly will it impact on my blood sugar? And when it does so, by how much and over what timescale? If I eat, say, a chocolate bar, which is about 30% by weight sugar, then sugars are very rapidly absorbed into the body. So I would say that would have a high glycemic index, because shortly after I ate the chocolate bar, I would begin to register an increase in blood sugar, and it would happen very quickly to a very high level, because basically all the sugar would be released in the intestine very rapidly, and all of it would be absorbed very rapidly, and all of it would end up in the blood. So you'd get this profound spike of sugar in the blood, and that would provoke insulin release from your pancreas, which would then rein in the sugar and sequester it in the form of a polymer of sugars called glycogen, or it would turn it into fat in your fat tissue, obviously. Now, if you eat food with a lower glycemic index, the rationale here is that the things they're made of are more complex carbohydrates, in other words, polymers of sugar, and they take longer to be released by enzymes and digestive juices. So the sugar trickles out from the foodstuff at a steadier rate. It doesn't peak in the blood so quickly, and it stays elevated for longer. So it therefore keeps you fed for longer and feeling less hungry for longer, but it doesn't produce that very profound, very high departure, which would lead to a large release of insulin. So when people are talking about eating a healthy diet that's good for, say, diabetic control or weight control, you go for foods which have a low glycemic index, because you don't want those enormous surges of glucose and sugars in your blood, which provokes insulin, which provokes you to then lay all that sugar down as flab. So some foods can be adjusted in terms of their constituents to achieve that, but you would struggle to do that with a chocolate bar. But you can do it with certain things like breads and that kind of thing. But to be honest, it's a relatively low glycemic thing if you've got wholemeal bread and that kind of thing anyway, because your body has to do some work to release the energy from it.
Thank you so much for that question. Sam, good morning to you.
Morning. There's a concept of the universe expanding, which is a concept I find very difficult to, in fact, get my head around. But the question I really want to ask is, black holes seem so large and absorbing. Do they counteract the concept of universal or the universe expanding?
Hello, Sam. Now, the answer is that black holes actually act on their patch of the cosmic neighbourhood. So at the centre of a galaxy like ours, we've got a massive black hole, and it is exerting some degree of gravitational influence over how things work in our galaxy. But it's not the only thing that's doing that, because if you look at, and this was an observation made by Fritz Zwicky a long time ago actually, and he noticed that the stars in galaxies are moving in a way that could not be explained just by the mass of the things we could see, such as inferring there's a black hole in the middle and the mass of the stars themselves. They're all whizzing round, orbiting something, but they're travelling at the wrong speed. What I mean by that is, if I put, say, a cup on a roundabout and I spun the roundabout, at a certain speed the cup would fly off the roundabout and disappear. And stars are going around in their galaxies at a speed as though the roundabout was turning far faster than the speed at which the cup should have flown off. So something else is hanging on to the stars in galaxies. And that something we now understand is dark matter. This is another entity about which we don't really understand very much, but it makes up about 28%, 27% of the mass of the universe. And it's very important because it's gravitationally active. Now that is helping to keep things together, again at a local scale. But across the whole of the universe, there is another force at work, which is dark energy. And this actually is the dominant presence in the universe. It makes up more than 70% of the mass of the universe. And dark energy is pushing things apart. So what's happening in the universe now is that you've got things like black holes, dark matter, and matter exerting gravity and holding bits of things together on local scales. But on the vast scales of the universe, you've got dark energy making the space between all of those entities get much bigger. So the universe is growing, and every year it grows bigger and bigger and bigger. It's still growing more slowly, though, than it did when it was first born, because when the universe was very young, just after the Big Bang, it actually inflated. And this is called the period of inflation. And in the space of about a 10,000th of a second, it got bigger by about a million times. In other words, one with about 25 noughts after it. So something made it get much bigger all of a sudden. So that was the biggest growth of the universe, and it's still growing today, but it's growing at a slower rate. But it's making the space between the things that have gravity get bigger. The things locally are being held in check by gravity, but on the vast scale, space is getting a lot bigger all the time.
Palesa, good morning.
Good morning, you Sirius and Chris. My question is, why is it, if the world is round, why is it that when a person travels from, say, America to China, they would have to travel eastward, and vice versa from China to America westward? Why not travel the other way around so that it's shorter? At least I assume you travel from China to America, you take a shorter time to travel if you traveled westward.
When one thinks about it and you look at a map, we often look at a map, and maps are drawn to fit into books. So they're nice on a flat sheet of paper, and they make it look very trivial to just draw a line from one part of the surface to another and say, I'm going to go from there to there. But of course, the Earth is a ball. Sorry to disabuse the people who continually phone radio programs and ask about the Earth being flat. This is not the case. The Earth's a ball. So actually, you have to consider that you're flying over a curved surface of a ball as well. So that has to be factored in. What's the shortest journey? The other thing to consider is the Earth is turning, and therefore the atmosphere that you're flying through is turning with the Earth, because as the Earth is turning and sweeping its way through the atmosphere is being caught up by the movement of the planet and accelerated alongside it. So the atmosphere is also moving. So if you fly in one direction, you're going to find it easier to fly than in the opposite direction. So aircraft companies, pilots, etc. take all these factors into account when they're plotting their route to work out what the fastest way to get from A to B is.
Thanks for your question, Palesa.
702. The Naked Scientist.
Tammy, good morning.
There's a comet in the space, sort of an ice storm that is moving towards our planet Earth. Like they were saying, sort of, if it happened that it crashed our planet, and then it's going to be the end of our life. So I just want to ask, is it that thing there or not?
Okay, thanks, Tammy. I also have an earworm now, Chris. It's the end of the world as we know it.
Do you know, I was thinking almost precisely the same thing. It's amazing how the brain works, isn't it? How certain stimuli recruit the same sorts of reactions in all of us.
Yes.
Thankfully, we're not aware of an impact due anytime soon, but there is a project looking for near-Earth objects. People at NASA, for example, are continuously scrutinising the skies, looking for things that might be on an earthbound course, because we know it can happen. The dinosaurs owe their demise, in part, to a huge impactor tens of kilometres across that rained in from space about 60 million years ago. Now, that object, in fact, people have done a post-mortem since, and they've worked out that probably was an object dislodged originally from the asteroid belt. And it was actually the pressure of light hitting objects in the asteroid belt and giving them a nudge. This is something called the YORP effect, Yarkovsky, O'Keefe, Radzievsky, Paddock effect, after the four scientists who actually independently described this. And it's where photons of light hit something and give it their momentum, so it nudges it a bit. And what effectively the sun shining on the asteroid belt did was to start joggling or jiggling some of the asteroids, so they bumped into each other and bits of them broke off, and some of those bits then felt the gravity from other bodies nearby and ended up on an earthbound course. Now, because our solar system is so vast, there's an enormous amount of material out there. We can't track all of it, and we can't see all of it to start with. So scientists are continuously looking to see if any objects are on an orbit that might intersect the Earth, and also if they're being dislodged or guided by gravity onto a path that the Earth may go through. Because if one of these things did hit the planet, then it doesn't have to be very big before it produces very considerable changes to things like the composition of the atmosphere, to the temperature and climate, and all those things are interlinked. And our ability to grow food on farms, if we can't see the sun because there's a huge amount of dust blocking out sunlight in the atmosphere, the whole planet's going to starve. So it's pretty important we understand when this is happening. The good news is that the planet's been here for 4.5 billion years or more, that actually most of the bombardment and impacting was going to be more frequent when the solar system was younger, and a lot of that's probably already been and gone. We also have a large moon, which helps to defend us from some of these things because they tend to hit that rather than hit the Earth half the time. So that helps. So on our side is the fact that A, we're here, so obviously it doesn't happen so frequently it can wipe out humans and complex life. And 2, most of it would have already been in the past when the solar system was younger, so the number of objects out there is fewer, but that doesn't mean we're not keeping an eye out just in case. Don't ask me the question, what are we going to do about it when we spot one, because I don't think, apart from Hollywood, anyone has crossed that bridge yet.
From the SMS line, Grace wants to know the following. I have found that I gather static electricity while in the car sometimes, and when I get out and touch the outside of the car, it shocks me. But now here's the interesting thing, says Grace. If I touch the window first, that seems to disperse the static electricity a bit, and it doesn't shock as badly. Could Chris explain the physics behind this?
I suspect that what's going on is that because Anne is expecting it and has touched the window, when it does actually happen, because she's expecting it and it's not such a shock, ba-boom, it's not as painful. Now, why does it happen in the first place? It happens because as your car is driving along, it's pushing air molecules out of the way. And those air molecules rub against the surface of the car and they exchange charges with the surface of your car. Because the car is insulated from Earth, because it's sitting on rubber tyres and rubber is a notoriously poor conductor, the charge can't seep away from the car very quickly once you stop driving. But when you step out of the car, you are now in contact with the Earth's surface, and also the amount of charge on you is different than the amount of charge on the metal outside parts of the car, because you were sitting inside the car on your seat, probably insulated from all that. So when you then touch the outside of the car, the electricity sees a different charge distribution between it and you, and it flows between the two of you to balance up the charge. And that's why you get a shock. And certain conditions are going to make this happen more. If you've got lots of nice dry air, that's going to make it happen a lot more than if you've got wetter air. So hot, dry days are going to make this happen more. I do think it's more psychological touching the glass, because the glass is an insulator. No current's going to flow through the glass between you and the glass, or very, very little, whereas the metal is a big capacitor. It's accumulated a big charge, it's a good conductor, and all of the charge then dissipates into your hand the minute you touch the metal part. So I think it's self-preparation, thinking, okay, I'm going to touch this, and then I'm going to psych myself up for the shock that's going to happen. Whereas if you step out the car and it happens and you weren't expecting it, it feels worse than it really is.
Thanks so much for sharing your wisdom and knowledge with us, Chris. We'll do it again, I don't know, but next week. That's what, Good Friday, is it?
I don't know, I can't remember. I've lost the will to live.
I'm not sure.
I've had some horrible cold which has left me completely. But we can talk next week. Let's do that. Let's try and do that.
Cheers. Thanks so much.
Bye-bye.